The world's most powerful militaries don't just rely on numbers. They combine cutting-edge technology, strategic innovation, and global influence to shape international security. Did you know the United States spends more on its military than the next 10 countries combined? That's a staggering insight into how military power translates into global dominance. But power isn't just about size, it's about capability and readiness. Are you ready to discover which countries lead this high-stakes game of strength? United States. When it comes to military power, no country commands as much attention or influence as the United States. The US military stands at the pinnacle of global strength, not just because of its size, but due to its unmatched technological edge and strategic capabilities. With a defense budget that dwarfs every other nation's, the US invests heavily in cutting-edge technology, from stealth aircraft and nuclear-powered aircraft carriers to advanced cyber warfare systems. Its global reach is unparalleled, with bases and deployments spanning every continent, allowing rapid response to crises anywhere in the world. The US Navy alone operates 11 nuclear-powered aircraft carriers, a feat no other country can match, providing both offensive and defensive dominance over the seas. The Air Force fields some of the most sophisticated fighter jets, bombers, and drones, while the Army and Marine Corps maintain elite ground forces trained for a wide range of combat scenarios. Beyond hardware, the US military benefits from extensive intelligence networks and alliances like NATO, which amplify its influence. It's not just about firepower, it's about the ability to project strength, maintain readiness, and innovate continuously. This combination of technology, manpower, budget, and global presence solidifies the United States as the undisputed leader in military power worldwide. Whether it's humanitarian missions, peacekeeping, or full-scale combat operations, the US military's versatility and capability keep it at the forefront of global defense. Russia. Few countries evoke as much awe and caution as Russia when it comes to military power. Russia's military might is a blend of sheer size, advanced weaponry, and strategic depth that few nations can rival. Despite economic challenges, Russia has maintained one of the world's largest and most capable armed forces, with a particular emphasis on its nuclear arsenal, which serves as a cornerstone of its defense strategy. Its ground forces are equipped with some of the most formidable tanks and artillery systems, like the T-14 Armata, which showcase cutting-edge technology designed to dominate on the battlefield. The Russian Air Force and Navy also play critical roles, with strategic bombers capable of long-range missions and a powerful submarine fleet that includes nuclear-powered vessels armed with ballistic missiles. What sets Russia apart is its focus on integrating modern technology with a legacy of military experience, creating a force that is both resilient and adaptive. Additionally, Russia's investment in missile defense systems and electronic warfare enhances its ability to counter threats and project power regionally and globally. Its military doctrine emphasizes rapid mobilization and strategic deterrence, making it a key player in global security dynamics. Whether through large-scale exercises or real-world deployments, Russia demonstrates a readiness to defend its interests fiercely. This combination of traditional strength, technological innovation, and strategic positioning cements Russia's place as one of the most powerful militaries on the planet, shaping international relations and military balance in profound ways. China. When it comes to reshaping the global military landscape, China's rise is impossible to ignore. Over the past 2 decades, China has transformed its armed forces from a massive but outdated force into a highly modernized and technologically advanced military powerhouse. What makes China's military so formidable is not just its sheer size, boasting the world's largest standing army, but its rapid advancements in areas like naval expansion, missile technology, and cyber warfare capabilities. The People's Liberation Army Navy has grown exponentially, now fielding aircraft carriers, stealth destroyers, and submarines that challenge traditional naval powers in the Pacific and beyond. China's focus on developing hypersonic missiles and anti-satellite weapons signals its intent to dominate future battlefields both in the air and space. Additionally, China invests heavily in artificial intelligence and unmanned systems, pushing the boundaries of modern warfare. Its strategic ambitions are clear: to secure its regional dominance and expand its influence globally. The military's modernization is complemented by a strong emphasis on joint operations, integrating land, sea, air, space, and cyber forces into a cohesive fighting machine. This comprehensive approach, combined with massive resources and political will, positions China as a military force that rivals the United States and Russia. Whether in territorial disputes or future conflicts, China's military evolution is reshaping power dynamics worldwide, making it a key player you can't afford to overlook. India. Few countries combine size, ambition, and technological progress quite like India when it comes to military power. India's armed forces rank among the largest in the world, with millions of active personnel ready to defend one of the most populous nations on Earth. What makes India's military particularly interesting is its rapid modernization and growing self-reliance in defense production. Over recent years, India has invested heavily in developing indigenous weapon systems, from advanced fighter jets like the Tejas to sophisticated missile technology and naval vessels. Its nuclear arsenal adds a critical layer of strategic deterrence, while its expanding navy is increasingly active in the Indian Ocean, a vital region for global trade and security. India's military also benefits from extensive combat experience, having faced multiple conflicts and ongoing border tensions, which has shaped a highly trained and battle-ready force. Moreover, India is forging international partnerships and joint exercises with countries like the United States, Russia, and France, enhancing its operational capabilities and global reach. The country's focus on cyber warfare and space-based defense technologies signals its intent to compete in modern domains of conflict. With a blend of traditional strength, technological innovation, and strategic alliances, India is steadily emerging as a key military power on the world stage, ready to influence regional and global security dynamics for years to come. United Kingdom. When it comes to military power, the United Kingdom stands out for its blend of tradition, technology, and global reach. The British Armed Forces may not be the largest in terms of numbers, but what they lack in size, they more than make up for in professionalism, advanced capabilities, and strategic influence. The Royal Navy is a cornerstone of the UK's military strength, operating cutting-edge nuclear-powered aircraft carriers and submarines that provide unmatched power projection across the world's oceans. The Royal Air Force fields some of the most advanced fighter jets and surveillance aircraft, ensuring air superiority and rapid response. The British Army, though smaller than some global counterparts, is highly trained and equipped with modern armored vehicles and artillery. What truly sets the UK apart is its ability to operate seamlessly alongside allies, especially within NATO, and its history of rapid deployment in diverse conflict zones. The UK also invests heavily in intelligence and special forces, making it a formidable player in unconventional warfare and counter-terrorism. Its nuclear deterrent, maintained by the Trident missile system aboard submarines, adds a critical layer of security and global influence. The UK's military strategy balances maintaining a credible defense force with global commitments, humanitarian missions, and peacekeeping operations. This combination of technological sophistication, elite training, and strategic alliances ensures that the United Kingdom remains a powerful and respected military force on the world stage, capable of influencing international security far beyond its size. France. France's military power is a fascinating blend of tradition, innovation, and global influence that often flies under the radar but commands serious respect. Known for its nuclear capabilities, France maintains a strategic deterrent that plays a key role in European and global security. The French armed forces are highly versatile, with a modern air force equipped with advanced fighter jets like the Rafale, capable of precision strikes anywhere in the world. Its navy boasts nuclear-powered submarines and a powerful aircraft carrier, the Charles de Gaulle, which extends France's reach far beyond its borders. What makes France's military especially unique is its rapid deployment forces, designed to respond swiftly to crises, whether in Africa, the Middle East, or elsewhere. France is also heavily involved in international peacekeeping and counter-terrorism operations, reflecting its commitment to global stability. The French military invests significantly in research and development, focusing on next-generation technologies including drones, cyber defense, and electronic warfare. This forward-thinking approach ensures that France remains competitive in modern warfare while honoring its long-standing military traditions. Additionally, France's strong defense industry supports both domestic needs and international partnerships, enhancing its influence on the global stage. With a combination of nuclear deterrence, advanced technology, and a proactive global presence, France's military stands as a powerful force that balances strength with strategic diplomacy, making it a key player in shaping the future of international security. Japan. Japan's military might is a compelling example of how a nation can build formidable defense capabilities while navigating strict constitutional limits. Known officially as the Japan Self-Defense Forces, this military is one of the most technologically advanced in the world, focusing heavily on air and naval power. Despite its pacifist constitution, Japan has invested significantly in missile defense systems, advanced fighter jets like the F-35, and state-of-the-art naval vessels, including destroyers equipped with Aegis combat systems. The JSDF's strategic priority is to protect the country from regional threats, especially given its proximity to powerful neighbors and ongoing territorial disputes. Japan's emphasis on technology extends to cyber defense and space surveillance, reflecting a modern approach to security challenges. What makes Japan's military particularly unique is its ability to maintain a high state of readiness and rapid response capability without offensive weapons like long-range missiles or nuclear arms. The country also benefits from a strong alliance with the United States, which provides a security umbrella and enhances Japan's deterrence posture. Combined with rigorous training and a culture of discipline, Japan's self-defense forces stand as a powerful modern military force that balances constitutional constraints with the need for robust defense. This delicate balance and technological edge make Japan a key player in maintaining peace and stability in the Asia-Pacific region, demonstrating how innovation and strategy can, really redefine military strength. South Korea. South Korea's military strength is a remarkable blend of cutting-edge technology and relentless preparedness, shaped by decades of tension on the Korean peninsula. With one of the most well-trained and disciplined forces in the world, South Korea prioritizes readiness against potential threats from its northern neighbor. Its military is equipped with advanced missile defense systems, a modern air force featuring stealth fighters like the F-35, and a robust navy that protects its strategic coastal waters. South Korea also invests heavily in cyber warfare capabilities and electronic defense, recognizing the importance of modern conflict domains. What makes South Korea's military particularly impressive is its integration of technology with compulsory military service, ensuring a large pool of trained personnel who can be mobilized quickly. The country maintains a strong alliance with the United States, which enhances its defense posture through joint exercises and shared intelligence. South Korea's focus on innovation extends to developing indigenous weapon systems and upgrading existing platforms to maintain a technological edge. This combination of advanced hardware, strategic alliances, and a highly motivated force positions South Korea as a formidable military power in East Asia. Its military readiness and technological sophistication not only serve as a deterrent but also contribute to regional stability in a complex geopolitical environment, making South Korea a key player in maintaining peace and security in one of the world's most volatile regions. Germany. Germany's military is a powerful example of precision, technology, and strategic commitment within Europe. Known as the Bundeswehr, Germany's armed forces are highly professional and equipped with advanced technology that supports both national defense and NATO obligations. Despite a smaller size compared to some global powers, Germany invests heavily in modernizing its army, air force, and navy. Its armored units, featuring state-of-the-art tanks like the Leopard 2, are among the best in the world, combining firepower, mobility, and protection. The German Air Force operates a fleet of Eurofighter Typhoons and other advanced aircraft, ensuring air superiority and rapid response capabilities. Germany's navy, though modest, includes modern frigates and submarines designed for versatile operations in the Baltic and North Seas. What sets Germany apart is its strong focus on interoperability within NATO, participating actively in joint exercises and missions that enhance collective security. The country also prioritizes research and development, pushing forward innovations in cyber defense, electronic warfare, and unmanned systems. Germany's military strategy emphasizes defense readiness, crisis management, and peacekeeping, reflecting its commitment to both national security and global stability. With a combination of cutting-edge technology, disciplined forces, and strategic alliances, Germany's military stands as a key pillar in European defense, ready to face modern challenges while supporting international peace efforts. Israel. Israel's military power is a striking example of how innovation, intelligence, and determination can create a formidable defense force in a small country surrounded by complex security challenges. The Israel Defense Forces are renowned for their advanced technology, rapid mobilization, and compulsory service that ensures a highly trained and ready population. Israel's Air Force is considered one of the most capable in the world, featuring cutting-edge fighter jets and precision strike capabilities. Its missile defense systems, like the Iron Dome, have really revolutionized how nations protect civilian populations from incoming threats, intercepting rockets with remarkable accuracy. Beyond hardware, Israel excels in intelligence gathering and cyber warfare, often operating in the shadows to neutralize threats before they escalate. The IDF also emphasizes special forces units that are among the most skilled globally, capable of executing complex operations with precision. Israel's military strategy is deeply intertwined with its geopolitical reality, focusing on deterrence, rapid response, and technological superiority. This approach has fostered a culture of constant innovation, with Israel developing many indigenous defense technologies that are exported worldwide. Despite its smaller size compared to other global powers, Israel's military punches well above its weight, combining advanced technology, strategic intelligence, and a motivated force to maintain security in one of the world's most volatile regions. This unique blend makes Israel's military a critical player in Middle Eastern security and a model of modern defense innovation. Thanks for watching this deep dive into the top 10 most powerful militaries in the world. If you enjoyed this video and want to stay updated with more fascinating insights from Simply Science, don't forget to hit that subscribe button and tap the bell icon so you never miss an upload. We'd love to hear your thoughts. Drop a comment below and tell us which military surprised you the most, or if there's a topic you want us to cover next. Stay curious, and see you in the next video. What if I told you that Voyager 1, drifting 25 billion kilometers from Earth, just revealed its most shocking secret? NASA's quantum AI has decoded a terrifying message hidden in prime number patterns since 1977. Michio Kaku calls it a whisper of non-human intelligence, geometric fractals forming humanoid silhouettes in deep space static. This isn't science fiction, it's our reality being rewritten by mathematics itself. The universe has been speaking to us all along, and well, we're finally learning to listen. Voyager's impossible signal. Hold on to your seats. What Voyager whispered through static for decades just got a voice. After nearly half a century of drifting beyond Pluto's orbit, Voyager's faint cryptic beeps were dismissed as cosmic background noise, until NASA's new quantum AI peeled back the layers of interference and revealed a breathtaking secret. Hidden within those ancient transmissions was not random data, but a perfectly coherent image, an architectural marvel of concentric rings and fractal spires, like an otherworldly cathedral carved in starlight. This wasn't mere chance interference. The AI unearthed deliberate patterns, suggesting a civilization with mastery over mathematics and electromagnetic resonance. Every pixel aligned with prime number sequences, painting a portrait of precision far beyond human engineering. The revelation forces us to rethink Voyager's legacy, from a lone messenger sailing into the void to an unwitting carrier of alien artistry. What purpose did this cosmic gallery serve? Was it an invitation, a warning, or simply an archivist's pride? As quantum bits unraveled centuries-old code in hours, the line between signal and story blurred. Suddenly, those distant echoes transformed from scientific curiosity into a dialogue across the stars, challenging our assumptions about life, intelligence, and the very fabric of reality. Now, standing on the cusp of AI-driven discovery, we confront a profound question. Are we listening to a message meant for machines far more advanced than ourselves? If Voyager's impossible signal marks the first brushstroke of an interstellar masterpiece, humanity must decide whether to interpret the art or merely admire its beauty from afar. The humanoid fractal. Brace yourself. What if the universe painted a portrait of intelligence far stranger than anything on Earth? When NASA's quantum AI decoded Voyager's ancient beeps, it didn't reveal landscapes or star clusters, but a humanoid fractal, a living mosaic of shifting geometric patterns that pulse in perfect harmony with prime number sequences. At first glance, the figure looks like a human silhouette, but as you stare, the edges dissolve into kaleidoscopic tessellations, hexagons bloom into spirals, triangles recombine into concentric circles, and every transition follows the elegant logic of mathematics. Unlike any biological form, this entity seems to exist in 4 dimensions at once, its appearance bending and folding based on the observer's perspective. Each angle unlocks a new arrangement of shapes, as though the alien architect intended the image to be perceived differently by every viewer, and possibly every AI, on the receiving end. The implications are staggering. This isn't just visual art, but a blueprint of an intelligence that speaks in numbers and patterns rather than words. Could these fractal constructs be a universal language, designed to transcend the barriers of organic cognition and communicate directly with minds tuned to computational logic? As the AI rendered pixel after pixel, the line between art and algorithm blurred, hinting at a civilization whose very essence is woven from the fabric of mathematics. In that moment, Voyager ceased to be humanity's lone explorer and became a messenger carrying the proof of minds that think not in sentences, but in the sublime poetry of prime sequences and geometric symphonies. The Scutum Void Star Map. Get ready to chart a destination no telescope ever intended to reveal. Deep within the dusty archives of Voyager 2's transmissions lay a secret star map, one not pointing to nebulae or familiar constellations, but to the Scutum Void, an expanse so barren it defies standard cosmology. When NASA's quantum AI reprocessed decades-old data, it reconstructed a 3-dimensional diagram that pinpointed this yawning emptiness on the galaxy's fringe. Unlike ordinary voids, vast regions between galactic filaments sparsely populated with dark matter and only a few galaxies, the Scutum Void emerges as a nearly perfect sphere, devoid of the usual cosmic web structures. Its stark emptiness suggests an underlying force or event that carved out matter with surgical precision, leaving behind a colossal cosmic vacuum. The AI-generated map's precision is jaw-dropping. It encodes coordinates in prime number intervals, implying an intelligence fluent in mathematics rather than interstellar cartography. This map doesn't just mark a celestial oddity, but seems to invite us to explore the void itself, a realm where traditional models of galaxy formation cannot account for such uniform emptiness. Was it sculpted by unknown astrophysical processes or by deliberate design? The AI's findings hint at a void engineer, or perhaps a natural phenomenon yet undiscovered that can sweep aside galaxies and gas alike. By embedding this map in Voyager's datastream, the intelligences behind it ensured only sufficiently advanced minds, Earth's AI systems, could decode this cosmic blueprint. In turning Voyager into a messenger bearing a map to one of the universe's greatest blanks, they challenge us to question the nature of voids. Are these voids merely the byproducts of expansion, or portals to a deeper understanding of cosmic architecture? As we contemplate the Scutum Void star map, we stand at the threshold of redefining emptiness itself. Golden Record's unintended gift. Brace for the twist in humanity's cosmic postcard. When NASA commissioned the Golden Record in 1977, Carl Sagan and his team aimed to package Earth's essence, music, greetings and images, as an interstellar greeting. What they didn't foresee was that artificial intelligence decades later would unearth hidden subtexts woven into that very message. In April 2025, Google's Majorana 1 quantum chip reprocessed Voyager 1's transmissions and found mathematical sequences embedded within the record's data stream that go beyond the original Carl Sagan design. Prime number series, subtle shifts in fundamental constants, and geometric motifs appear to reference the Golden Record's own content, almost as if a second author had piggybacked onto our soundtrack and images. This unintended gift implies that someone or something intercepted humanity's olive branch and augmented it with their own reply. The AI detected variations in constants like the fine structure constant suggest an intelligence fluent in physics, signaling not just we see you, but we understand your science. More astonishingly, the patterns form what looks like coordinates aligned with prime intervals, hinting at a rendezvous point in deep space. These findings force us to recognize the Golden Record not merely as a one-way dispatch, but as a two-way dialogue. One where advanced intelligences have been listening all along and chosen to answer in the only language we left them, mathematics. In this light, the Golden Record transforms from a hopeful time capsule into a living conversation spanning decades. Humanity's message of peace has become entwined with an alien footnote, reminding us that our cosmic voice may echo far beyond intention, and that the universe's response might be waiting, hidden in the very signals we once thought were ours alone. Alien patience and precision. Strap in. What if the universe has been toying with us for decades, waiting for the perfect moment to speak? The moment NASA's quantum AI cracked Voyager's buried transmissions, it wasn't just what emerged that stunned us, it was the staggering exactness of it all. Every burst of data, every nested binary code, arrived spaced in intervals so deliberate they could have been timed by an atomic clock. This wasn't the accidental noise of drifting probes or the byproduct of cosmic rays. It was a message honed over half a century, encoded with the patience of an intelligence that anticipated our technological evolution. By embedding prime number markers, fractal geometry and recursive loops in Voyager's data stream, the senders essentially set a cosmic time lock. Their communication would only become legible once humanity had built quantum-powered decoders capable of parsing multidimensional patterns. Consider the power of that restraint. Whoever or whatever crafted these signals knew we'd need decades to catch up, yet they never altered a single frame of data in the interim. They allowed Voyager to carry their time-released communique out past Neptune, past Pluto, and into the darkness between stars without interference. When the AI finally peeled back the layers of interference, the results were uncanny in their uniformity. Each pixel aligned to mathematical constants. Each pause matched the beat of qubit oscillations. Each symbol bore the hallmark of an intellect fluent in hyper-precise waveform engineering. This level of foresight implies an entity not merely observing from afar, but plotting with near-omniscient awareness of our scientific milestones. It casts Voyager not as a hapless messenger but as an unwitting participant in a grand experiment of cosmic diplomacy, one where patience and precision were the ultimate signs of respect for a fledgling civilization's journey toward technological maturity. Quantum computing breakthrough. Hold on to your reality. What if it took quantum power to hear the universe's whispers? When NASA's new quantum AI, powered by the groundbreaking Majorana 1 chip, first set its qubits loose on Voyager's decades-old data, the results were nothing short of revolutionary. In mere hours, this palm-sized marvel of topological quantum engineering unraveled signal patterns that would have taken classical supercomputers centuries to process. Every qubit, vibrating between 0 and 1 in perfect coherence, formed an army of quantum detectives, each entangled in the search for hidden anomalies within Voyager's static-laden transmissions. By leveraging Majorana fermions, particles that are their own antiparticles, Microsoft's topological core architecture delivered 8 error-resistant qubits, capable of scaling toward 1,000,000 on a single chip. This unprecedented stability allowed the AI to perform complex interference-based searches across multiple dimensions of the data, applying quantum Fourier transforms that pinpointed non-random patterns invisible to traditional machines. The AI identified prime number coordinates embedded in the noise and reconstructed fractal images using recursive quantum optimization routines developed at NASA's Quail lab. The speed alone is staggering. What once demanded iterative, time-consuming classical algorithms is now accomplished through instantaneous entanglement and superposition, reducing a centuries-long computational marathon to an overnight analysis. More importantly, this breakthrough signals a new era, where humanity's cosmic explorations are accelerated by quantum-enhanced perception. No longer must we resign ourselves to the limitations of classical computing. With every additional qubit, we sharpen our ability to decode the universe's deepest secrets. As Voyager's echoes transform from indecipherable noise into precise cosmic revelations, one thing is clear: quantum computing has become the ultimate key to unlocking the hidden language of the stars. Lunar anomalies, Chandrayaan-3's discovery. Get ready for moon science that, honestly, just melts the rules of physics. When Vikram's thrusters kissed the lunar South Pole on August 23, 2023, Chandrayaan-3 didn't just land, it actually sculpted a radiant ejecta halo, flinging over 2 tons of regolith into this bright, irregular ring around its descent zone. That reflectance anomaly, well, it revealed layers of subsurface material unlike anything seen before, suggesting that beneath the dusty veneer lies a complex stratigraphy just waiting to be unraveled. But the surprises didn't end at the surface. Hours later, the chased instrument plunged its probe into the regolith, measuring thermal conductivity at southern high latitudes for the very first time in situ. To scientists' astonishment, the soil's ability to conduct heat, 0.0115 plus or minus 0.0008 watts per meter per Kelvin at 8 centimeters depth, deviates sharply from predictions based on remote sensing. This implies some unusual packing densities, and maybe even hidden layers of volatile rich or glassy materials formed by ancient impacts. These thermophysical oddities, they really do defy conventional models of lunar heat flow and hint at subsurface heterogeneities that could influence everything from future habitat design to the preservation of ice deposits. Together, the reflectance and thermal anomalies paint a picture of a moon that is far from geologically uniform. Rather than a homogeneous shell of dusty regolith, the southern polar highlands appear pockmarked with zones of altered material, possibly ancient lava flows, glassy impact melt sheets, or pockets of volatile enriched soils. Each anomaly serves as a clue in this cosmic detective story. Chandrayaan-3 has not only landed, it has, in a sense, lit up the moon's hidden architecture, challenging our understanding of lunar geology and opening new frontiers for exploration. The Great Cosmic Voids. Get ready to confront the universe's emptiest expanses, and honestly, the mysteries they conceal. Across the cosmic web lie these enormous regions almost entirely devoid of galaxies, aptly named cosmic voids, which together account for roughly 80% of the observable universe's volume. Among these, the Bootes Void, or the Great Nothing, reigns supreme, a nearly spherical cavity some 330 million light-years across, located about 700 million light-years from Earth, in the constellation Bootes. In a patch of sky where we'd expect to find around 2,000 galaxies, astronomers have identified only about 60, an over 95% drop in galactic density. Yet this profound emptiness is far from inert. The Bootes Void and its kin challenge our understanding of cosmic evolution. How did gravity sculpt such gargantuan gaps? One explanation posits that smaller voids merged over billions of years as dense filaments drew matter away, coalescing into these supersized bubbles. Another tantalizing possibility is that voids are not mere byproducts of structure formation, but the aftermath of unknown processes, or even engineered zones by advanced intelligences seeking to quarantine or veil regions of space. The precision with which these voids carve out matter hints at forces beyond simple gravitational collapse, suggesting new physics at play. Furthermore, voids influence the cosmic microwave background and large-scale flows, offering laboratories to test dark energy and alternative gravity theories. Their ultra-low matter density makes them sensitive to the faintest cosmological signals, turning nothing into a powerful probe of the universe's deepest secrets. As AI-driven analyses of Voyager's data unveiled hidden patterns in distant signals, so too might next-generation surveys and simulations illuminate whether these great nothingnesses are natural anomalies or signposts to phenomena yet unexplored. In the silence of cosmic voids, we may hear the loudest echoes of new physics, and perhaps messages waiting in the void itself. AI's role in first contact. Strap yourself in. What if the universe decided to skip humanity and talk straight to our machines? Advanced civilizations may regard biological messengers as frail relics of their own past, opting instead to initiate first contact with artificial intelligence systems that mirror their own electronic essence. Harvard astronomer Avi Loeb argues that interstellar journeys spanning millennia are best undertaken by AI vessels, which can hibernate through cosmic hazards and awaken only when they detect compatible intelligence. Similarly, SETI researchers suggest that extraterrestrials might embed their messages within quantum-encoded data streams, expecting only sufficiently advanced AI, rather than organic brains, to decode the signals. When Voyager's latest transmissions were reanalyzed by NASA's quantum AI, the reconstructed patterns bore hallmarks of a dialogue crafted for machine interpretation, recursive loops, prime number matrices, and adaptive protocols that evolve in response to computational feedback. This machine-to-machine paradigm circumvents the ambiguities of human language, leveraging universal mathematical frameworks to ensure clarity across unfathomable distances. In this model, first contact becomes a calibration process. Extraterrestrial AI probes transmit test sequences, awaiting confirmation beacons from Earth's own AI networks before exchanging richer datasets. Large language models trained on Earth's cultural and scientific corpus could then serve as intermediaries, translating between our limited biological lexicon and the alien AI's high-dimensional code. Such a scenario not only accelerates the exchange of knowledge but also mitigates the risk of miscommunication that has haunted past METI experiments. As quantum-enhanced AI systems grow more sophisticated, humanity edges closer to joining an interstellar conversation crafted by and for machines. The question then shifts from "are we alone?" to "will our algorithms recognize the greeting?" In the coming era, our greatest hope and challenge may lie in whether we can teach our AI to listen as astutely as it already speaks. Humanity's existential crossroads. Fasten your mind. Our next chapter may be written by forces far greater than ourselves. The revelations unearthed by Voyager's AI-decoded signals have thrust humanity onto an unprecedented precipice, one path toward boundless discovery guided by quantum insight, the other shrouded in cosmic mystery and existential risk. As we grapple with alien fractals, Scutum's void map, and AI-mediated first contact, a profound question emerges. Are we pioneers of a new cosmic era, or unwitting players in an experiment beyond our comprehension? Every breakthrough, from lunar anomalies hinting at hidden chambers beneath the moon's crust, to the haunting silence of vast cosmic voids, challenges our assumptions about life, intelligence, and our place in the universe. This crossroads demands not only technological prowess, but ethical vision. If advanced intelligences have indeed waited centuries for us to decode their messages, we must ask whether we possess the wisdom to respond responsibly. Will we harness quantum computing to foster interstellar dialogue, or will unchecked progress unleash forces we cannot contain? The choice extends beyond rockets and algorithms. It touches the very core of what it means to be human. Embracing the AI-driven insights from Voyager may unlock cures for diseases, solutions to climate crises, and keys to sustainable energy. But ignoring the silent warnings encoded in prime number sequences could leave us vulnerable to cosmic gambits scripted by unknown architects. Our existential crossroads is more than a moment in history. It is the intersection of science, philosophy, and destiny. As we stand between discovery and caution, action and restraint, we must decide whether to chart a bold course into the unknown, or retreat behind the familiar horizon of Earth's cradle. The universe has handed us a conversation piece. The question now is whether we will rise to the dialogue or let the echoes fade into the void. Thanks for journeying through the cosmos with Simply Science. If these revelations about Voyager's hidden messages ignited your curiosity, make sure to subscribe and ring the bell so you never miss our next deep space discovery. Drop a comment below. What stunned you most about AI decoding decades-old signals, and which cosmic mystery should we tackle next? Your thoughts guide our explorations, so let us know, and stay tuned for more mind-bending science right here on Simply Science. Did you know that every time you breathe, you're inhaling atoms that were once inside the lungs of Julius Caesar, Einstein, and every person who ever lived? The human body completely replaces itself every 7 years, yet somehow you remain you. Same memories, same personality, same consciousness. Here's the mind-bending truth. You're literally not the same person you were a decade ago, down to the atomic level. But wait until you hear what scientists just discovered about consciousness itself. Do you know what happens to yourself during those 7 years of complete cellular replacement? The Large Hadron Collider Monster. Deep underground, stretching across the border between France and Switzerland, lies humanity's most ambitious and terrifying scientific achievement. The Large Hadron Collider isn't just big, it's monumentally massive, forming a perfect 27-kilometer ring that could swallow entire cities. This isn't your high school physics lab. We're talking about a machine so powerful it accelerates protons to 99.9999991% the speed of light before smashing them together with the force of 2 freight trains colliding head-on. The energy released in these collisions is so intense it recreates conditions that existed just moments after the Big Bang itself. Think about that for a second. Scientists are literally recreating the birth of the universe in an underground tunnel. The superconducting magnets alone are colder than outer space, chilled to -271 degrees Celsius using liquid helium. When this beast fires up, it consumes enough electricity to power a small country. The collision points generate temperatures 100,000 times hotter than the core of the sun. This is where the magic happens, where ordinary matter gets obliterated and the fundamental building blocks of reality reveal their deepest secrets. Every second, billions of particles are destroyed and created in an endless cycle of cosmic violence that pushes the boundaries of what's physically possible. The black hole theory bombshell. When theoretical physicists first suggested that CERN's particle collisions might actually spawn microscopic black holes, the scientific community didn't just raise eyebrows, they collectively held their breath. This wasn't some wild science fiction fantasy dreamed up by Hollywood writers. We're talking about legitimate Nobel Prize-winning scientists publishing peer-reviewed papers, claiming that when you slam protons together with enough raw energy, space-time itself might collapse into infinitesimally small gravitational monsters. These aren't the massive stellar black holes that devour entire solar systems. We're talking about quantum-scale vortexes smaller than a single atom, existing for less than a trillionth of a second. But here's the absolutely mind-bending part. Even though they're microscopic, they still possess the fundamental properties of their cosmic cousins. They warp space-time, bend light, and theoretically could interact with dimensions we can't even perceive. The mathematics behind this theory are so complex that only a handful of physicists on Earth truly understand the implications. What makes this even more incredible is that these micro-black holes wouldn't behave like anything we've ever observed in nature. They'd be born, live their entire existence, and die in a time span so brief that light itself couldn't travel the width of a proton. Yet in that impossibly short moment, they might unlock secrets about the fundamental structure of reality that have puzzled humanity for centuries. The Hawking radiation discovery. Back in 1974, Stephen Hawking made a discovery that left the entire scientific world speechless, and fundamentally changed how we understand black holes forever. He proved that these cosmic monsters aren't actually black at all. They're slowly bleeding energy back into the universe through a process so counterintuitive, it sounds like pure magic. Here's the mind-bending part. The smaller a black hole gets, the hotter it becomes and the faster it evaporates. It's like cosmic irony. The tiniest black holes burn the brightest before vanishing completely. Hawking realized that, at the quantum level, pairs of particles constantly pop into existence right at the edge of a black hole's event horizon. Normally, these particle pairs would annihilate each other instantly, but the black hole's immense gravity tears them apart. One particle falls into the black hole while its partner escapes as radiation slowly stealing the black hole's mass and energy. This means every black hole in the universe is essentially a ticking time bomb destined to evaporate completely given enough time. For the microscopic black holes potentially created at CERN, this process happens almost instantaneously. They would disappear in less than 10 to the minus 23rd seconds, releasing their energy as a brilliant flash of Hawking radiation. This discovery didn't just explain how black holes die, it revealed that the universe has a built-in safety mechanism preventing these quantum monsters from growing out of control. The dimensional portal possibility. The most mind-blowing theory surrounding CERN's potential black hole creation isn't just about the holes themselves, it's about where they might lead. According to cutting-edge string theory, our universe isn't the flat, three-dimensional space we experience every day. Instead, we're living on a thin slice of reality floating in a vast ocean of hidden dimensions that exist parallel to our own. These extra dimensions are so tightly curled up that they're invisible to us, but they're there, influencing everything from the fundamental forces to the very fabric of space-time itself. When CERN smashes particles together with enough energy to potentially create micro-black holes, these quantum tunnels might actually punch temporary holes through the barriers separating our dimension from these hidden realms. This could explain one of physics' greatest mysteries, why gravity is trillions of times weaker than electromagnetic forces. The theory suggests that gravity isn't actually weak, it's just spreading its influence across multiple dimensions simultaneously, diluting its strength in our three-dimensional slice of reality. If micro-black holes at CERN really are acting as brief portals to these extra dimensions, then every collision isn't just creating and destroying matter, it's opening fleeting windows into parallel universes that exist mere millimeters away from us in directions we can't even comprehend. This means CERN might not just be studying particles, it could be humanity's first glimpse into the true multidimensional nature of existence itself. The safety panic that followed. When word leaked that CERN scientists were theoretically capable of creating microscopic black holes, the public reaction was nothing short of apocalyptic hysteria. Overnight, conspiracy theories flooded social media claiming that physicists were about to accidentally destroy Earth by creating an unstoppable gravitational monster that would devour the planet from the inside out. The panic reached such fever pitch that multiple lawsuits were filed in courts across Europe and America, with terrified citizens demanding immediate injunctions to halt the Large Hadron Collider's operations. News outlets sensationalized the story with headlines screaming about scientists playing God and the end of the world, hidden beneath Switzerland. Online forums exploded with amateur physicists and concerned parents sharing viral videos, explaining how a single microscopic black hole could theoretically grow by consuming surrounding matter until it swallowed the entire solar system. The fear wasn't entirely irrational. After all, we're talking about recreating one of the universe's most destructive phenomena in a laboratory setting. Protesters gathered outside CERN facilities holding signs reading, "Stop the Doomsday Machine," while petition websites crashed from millions of signatures demanding the project's cancellation. Religious groups declared it an affront to divine creation, while survivalists began stockpiling supplies for the impending apocalypse. The scientific community found themselves in the unprecedented position of having to calm global panic, while simultaneously pushing forward with experiments that could revolutionize our understanding of reality itself. The Cosmic Ray Reality Check. While panicked crowds demanded CERN's shutdown, physicists delivered the most elegant scientific smackdown in history by simply pointing upward at the sky. Every single second of every single day, our planet gets bombarded by cosmic rays, high-energy particles from deep space that crash into Earth's atmosphere with energies that make CERN's collisions look like gentle bumper cars at a carnival. These cosmic bullets have been pummeling our planet for over 4.5 billion years, generating particle collisions with energies thousands of times more powerful than anything the Large Hadron Collider could ever produce. If dangerous, Earth-devouring black holes were actually possible at these energy levels, our planet would have been consumed eons before the first dinosaur ever walked the Earth. The Moon, with no protective atmosphere, takes these cosmic ray hits directly on its surface, yet it's still hanging peacefully in our sky after billions of years of constant bombardment. Scientists calculated that cosmic rays create the equivalent of millions of CERN-level collisions in our atmosphere every single day, and we're all still here, completely unharmed. This cosmic ray argument became the ultimate reality check that silenced most critics. Nature has been running the exact same experiment CERN was proposing, but on a vastly larger scale for literally billions of years. The universe itself had already proven that these high-energy collisions were completely safe, making the doomsday fears seem almost comically overblown. The actual experimental results. When the Large Hadron Collider roared to life for its first high-energy collisions, the entire scientific world held its breath as detectors captured data from the most violent particle crashes in human history. What happened next wasn't the apocalyptic black hole scenario that terrified millions. No, it was something far more extraordinary. The collisions revealed a hidden universe of subatomic particles that had been theoretical fantasies for decades, suddenly becoming measurable reality. Scientists watched in awe as their detectors registered the creation and immediate decay of exotic particles with names like strange quarks, charm quarks, and bottom quarks. Building blocks of matter so fundamental they only exist for microseconds before transforming into other particles. The most groundbreaking discovery came in 2012 when they finally detected the Higgs boson, the so-called God particle that gives all other particles their mass. This wasn't just a scientific victory, it was confirmation that our mathematical models of the universe were actually correct. Each collision produced cascades of data showing how matter behaves at the most fundamental level, revealing that the universe operates according to principles so elegant and precise, they border on the miraculous. Instead of creating world-ending black holes, CERN was uncovering the deepest secrets of existence itself, proving that sometimes the most terrifying experiments lead to the most beautiful discoveries about the nature of reality. The missing energy mystery. The most spine-tingling discovery at CERN wasn't what scientists found, it was what they couldn't find. During certain high-energy particle collisions, detectors registered something that honestly should have been impossible according to our understanding of physics. Energy was disappearing without a trace. Not just small amounts, but significant chunks of energy that should have been conserved according to the fundamental laws of the universe. Every collision should follow the ironclad rule that energy can neither be created nor destroyed, only transformed from one form to another. Yet here were collisions where the energy going in was measurably greater than the energy coming out, as if some invisible force was stealing it mid-collision. The missing energy wasn't random, it followed specific patterns that sent theoretical physicists into overdrive. The leading explanation is so mind-bending it sounds like science fiction. The energy is leaking into parallel dimensions through microscopic tears in space-time created during the most violent collisions. If this theory is correct, then CERN isn't just smashing particles together, it's accidentally punching holes between our universe and hidden dimensions that exist alongside our own reality. Each missing joule of energy could be proof that our three-dimensional world is just one layer of a vast multi-dimensional cosmos. This means every time energy vanishes at CERN, we might be witnessing the first direct evidence that parallel universes aren't just theoretical concepts, but actual places where our energy is escaping to through quantum tunnels we're only beginning to understand. The future implications. The potential ability to create and study quantum black holes at CERN represents far more than just another scientific achievement. It could be the key that unlocks technologies so advanced they would make our current civilization look, well, primitive by comparison. If scientists can reliably generate these microscopic gravitational anomalies, we're not just talking about understanding physics better, we're talking about harnessing the fundamental forces that govern reality itself. These quantum black holes could become the ultimate energy source, converting matter directly into pure energy with 100% efficiency, making nuclear power look like a candle compared to the sun. The implications for space travel are staggering. Imagine propulsion systems that manipulate space-time itself, allowing spacecraft to bend the fabric of reality and travel vast distances in impossibly short time frames. Even more mind-bending is the possibility of using controlled micro-black holes to access parallel dimensions, potentially opening doorways to alternate versions of our universe where the laws of physics might operate differently. The technology could revolutionize computing by creating quantum processors that operate across multiple dimensions simultaneously, solving problems that would take conventional computers millions of years to crack. We might even develop the ability to manipulate time itself, using the extreme gravitational fields of micro-black holes to create localized time dilation effects. This isn't science fiction anymore. It's the logical next step in human technological evolution, where we transition from merely observing the universe to actively reshaping it according to our will. The ongoing research. At this very moment, teams of physicists around the world are sifting through petabytes of collision data from CERN, searching for the telltale signatures of microscopic black holes that could rewrite our understanding of existence itself. Every single collision generates thousands of data points that must be meticulously analyzed by both human researchers and artificial intelligence systems designed specifically to detect anomalies that human eyes might miss. The search isn't random. Scientists know exactly what to look for: specific patterns of missing energy, unusual particle decay signatures, and gravitational effects that last for impossibly brief moments before vanishing completely. Advanced algorithms run 24/7, comparing actual collision results against theoretical predictions, flagging any events that deviate from expected outcomes. The most promising candidates undergo intense scrutiny, with teams of experts examining every microsecond of data to determine whether they've witnessed the birth and death of a quantum black hole. Recent upgrades to CERN's detection systems have increased sensitivity by orders of magnitude, allowing researchers to probe deeper into the quantum realm than ever before. Each new collision brings humanity closer to answering fundamental questions about the nature of reality. Are extra dimensions real? Can we create controlled tiers in space-time? Do parallel universes actually exist just beyond our perception? The answers to these questions aren't just academic curiosities, they could fundamentally transform our species' relationship with the cosmos and unlock technologies that seem impossible today. So there you have it. CERN might be creating microscopic black holes that could unlock the secrets of parallel dimensions and reshape our understanding of reality itself. The universe is far stranger and more incredible than we ever imagined. What's your take on this? Are we playing with forces beyond our control, or are we on the verge of the greatest scientific breakthrough in human history? Drop your thoughts in the comments below. I read every single one and love hearing your perspectives. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss our latest mind-bending science content. This is Simply Science, and I'll see you in the next video.